Hello! Welcome to our final video on binomial hypothesis testing, where we're finishing things off by showing you how to do the conclusion for the hypothesis test. Because we've had several videos by now on this channel covering binomial hypothesis testing, you might be wondering what specifically we're covering in this particular video. So just to make that clear, we are showing you how to decide whether to reject H0 or not for both the critical region method for a hypothesis test and also the p-value method as well. And then once you've come to that decision, then how to word your answer to fully respond to the original wording in the question. Because we're covering all these different aspects of this stuff, I will include chapters for this video so you can navigate to the part that's relevant to you if you only want to watch a particular part. But anyway, let's start by trying to get our heads around what we're actually trying to do here. So, for a hypothesis test, you're usually given two main bits of information as part of it. First of all, you're probably given a test statistic, which specifically for a binomial hypothesis test is a number of successes, a measure for your variable which will often be x but could be any other letter, so pay attention to what the question says. But then you're also given in the question a significance level. And the thing about a significance level is it is at its core a probability. Simply put, it's the likelihood that the test statistic will cause us to call into question the validity of the null hypothesis. But either way you look at it, the problem is we've got two different measurements that are on two different scales, and therefore we can't currently compare them. So ultimately, both methods for doing a hypothesis test are both concerned with just trying to even these things up so they're both on the same scale, so that they can be directly compared to each other. For instance, if we take the significance level and use it to decide what is the range of number of successes that's most unlikely, then this is what we're doing when we're finding a critical region. Because once you've done that, we now have two things that are measuring the number of successes that we can therefore directly compare to each other. And to refer back to an example I explained in a previous video on critical regions, I said that if you're rolling a dice that's assumed to be fair 600 times, then you'd expect to get 100 fours. But therefore, if you got 101 fours, you would think that's fairly realistic. Whereas if you rolled it 600 times and got 599 fours, that would make you start to question whether the dice actually was fair. So finding a critical region is just about drawing the line at what point you'll start calling a number of successes suspicious. And so therefore once you've found the critical region, it's just as simple as just checking whether the test statistic is in the critical region or not. If it is in the critical region, then you're saying it's included within that range of suspicious values, and therefore that's enough for you to say that we're going to be rejecting H0, the null hypothesis. Whereas if the test statistic is not in the critical region, it's within the range of values that's realistic, and therefore we don't have a reason to reject H0, so you say do not reject H0. And so to see this in action, let's do three examples. I've cut out the words and just jumped straight to the important bits of information you'd get from a hypothesis test. So given this information, we could calculate a critical region, and for this information, that would lead to this. I have skipped the working for that as well, but that's just because I've already got a video explaining how to do critical regions, so if you need more practice at that, do watch that video, or alternatively, also try this stuff yourself, see if you get the same numbers as me. It is worth noting, because I haven't included any additional wording, we have to default to the base assumption that the critical region can't exceed the significance level. But given that this is our critical region, we can now compare that to the test statistic to see if it lies in it. But as our test statistic is x equals 7, 7 is not less than or equal to 6. It's greater than 6. So therefore it's not in the critical region, and therefore we do not reject H0. So there you go. That's the first one done. Another example, this time we're looking at an upper tail, and therefore our critical region is a greater or equal to style critical region. But we still once again just look at our test statistic and decide, is it in the critical region or not? Unfortunately, 9 is in the critical region, so therefore we do reject H0, as 9 is in our critical region. And on to example 3, which is a two-tail test, and therefore as a result, the critical region is two separate intervals. However, the same logic as before still applies. The test statistic just needs to lie somewhere within the critical region in order for us to reject H0. The test statistic will never lie in both intervals at the same time, but that doesn't matter, it just has to lie in one of the intervals in order for us to reject H0. Whereas if it doesn't lie in either of them, we do not reject H0. So in this case, we've got y is equal to 127 as our test statistic, as 127 is not less than or equal to 124 and not greater or equal to 162, therefore 127 is not in the critical region. And therefore, as a result, we do not reject H0 in this example. Okay, so that's how you use a critical region to decide whether or not to reject H0, but how do you do it if you've got a p-value? The p-value kind of does what the critical region method did, but in reverse. Instead of trying to convert the significance level to a number of successes, so it can be compared to the test statistic, we convert the test statistic to a probability, which is what we call the p-value, so that once again it then can be compared with that other bit of information given in the question for a hypothesis test. But then, how do we interpret what that p-value is trying to tell us? Well, as I've just pointed out, the p-value is a probability, so therefore that means it lies on a scale in between 0 and 1. And therefore also the significance level does as well. All you need to do is to decide whether the p-value is lying in this region here on the number line. If it's between the number 0 and the significance level written as a probability, then therefore this is the bad zone, and therefore it means we're going to reject H0. Whereas if the p-value is in between the significance level and the number 1, this is the good zone, which will lead to us not rejecting H0. And it's as simple as that. It doesn't matter if you're doing a lower tail test, an upper tail test, or a two-tail test. It's always going to be this scale, and it's always going to be the case that below the significance level is the place where we reject H0, and above the significance level is where we do not reject H0. But therefore, a little rhyme that some students like to use to help them remember this fact is that if p-value is low, HO must go. Unfortunately, I can't take credit for that one. It was passed on to me by one of my colleagues, and despite being somebody who normally doesn't like these sort of little rhymes for remembering things, this one is particularly catchy, so I thought I'd pass it on as it's quite useful for remembering this stuff. And so let's now apply the p-value method to the same three examples we did the critical region method with, because ultimately you should get the same conclusion regardless of whether you use the critical region or p-value methods. Once again, I'm just going to skip straight ahead to having already calculated the p-value. But if you need a reminder or an explanation of how to calculate p-values, do watch my video covering that method. A link to that appears on the screen right now, and funny enough, these examples are the same examples I did for that, so you can see exactly what calculation I did to calculate these p-values. But anyway, as I already pointed out, the p-value is a probability, so lies on a scale between 0 and 1. We then need to identify the significance level, which as a decimal would be therefore 0.05, as we had 5% as our significance level here. And then we need to just see where is the p-value on this same scale. Well, ultimately, as it's 0.07, that would be somewhere to the right of our significance level. Therefore, it's not going to be in this region here, which is the bit that would cause us to reject H0. It's in the safe area. So therefore, as 0.0719, etc., is greater than 0.05, it's therefore the case where we do not reject H0. Okay, on to our second example. Once again, calculating the p-value already, we get this. Once again, we draw a number line going from 0 all the way to 1. We know our significance level this time though is 10%, which would be 0.1. And this time our p-value is 0.072998804, which is quite similar actually to the one we had in the previous question, but therefore it is somewhere to the left of 0.1. That is important therefore because it means that our p-value is in the region that would cause us to be suspicious about H0, because it is less than our significance level. So therefore we are going to reject H0. On to a third and final example. Again, we've got the two-tail test. But guess what? actually, for a p-value method, once you've calculated the p-value, which is this one, then it's actually not very difficult to interpret. We still just draw the number line from 0 to 1. We still look at our significance level, in this case 8%, so 0.08, and it's still only the bit to the left of the significance level that's the region that would cause us to reject H0. But as our p-value is not to the left of 0.08 on the number line, it's to the right, therefore we do not reject H0. Because, to make it clear, 0.1259462 is greater than our significance level. And so there you go. That's how you use the p-value method to decide whether or not to reject H0. But sadly, that's not the end of the question, because regardless of whether you have used the p-value method or the critical region method to make your decision, you then do need to make sure you've written a proper conclusion to fully answer the question. And therefore, that's what we're going to take a look at right now. What do you need to write in that conclusion to properly answer it? In fact, that's a good thing to start with. The reason that we're actually having to do this, which is that we're wanting to do it to make sure that we've actually fully responded to the original claim that's in the question. The reason for that is kind of reflecting what you'd have to do in the real world. If you're having to do a hypothesis test, it's often because somebody else has made a claim and they're wanting to know whether it's true or not. And therefore, a lot of the stuff we've written as part of doing the hypothesis test was just mathematical notation, and therefore it's not going to mean much to the person asking the question. They just want you to answer their original question directly, so it's important that you do it. And therefore it's important you put your answer back into context, to relate it back to the scenario they were talking about. However, you also need to be aware that the conclusions you make from hypothesis tests are not a guarantee. And that's because everything we were doing with hypothesis tests was related to probabilities, and the cutoff point about whether we did or didn't reject H0 was based on the probability of the significance level. So therefore you do need to refer to the fact that your conclusion that you are making is only because of the particular significance level that you used when doing that hypothesis test. So referencing that in your words is important. So these are the things you need to consider when trying to write the wording for your conclusion, but therefore let's have a go at actually doing that ourselves. But the thing is, the examples we were looking at earlier in this video were a bit bare bones. They only had the numbers and basic information needed to do the calculations for those examples. However, I had extracted that information from an original scenario, so therefore we're going to take a look back at what those actual original scenarios were before I had extracted that information. Funny enough though, these examples were all examples I looked at in one of my previous videos on binomial hypothesis testing, where I showed how you can extract that sort of information from words. So therefore, if you'd like to see me go through how to extract that information, then do take a look at that video, a link to which is appearing on the screen right now. But anyway, this is the same scenario that we were referring to when we were doing example 1 earlier in this video, even though it didn't look like this because we didn't have all these words, but therefore it's worth pointing out we had made the conclusion already that we were not going to reject H0. So therefore the first thing you need to include in your conclusion is basically some wording that relates back to the scenario but still gives this impression of not rejecting H0. Because of the way hypothesis tests are set up, the implication is that if you're not rejecting H0, that means you are rejecting H1. And most of the time, it's the wording of the claim given in the scenario that influenced what H1 was when you're setting up your hypothesis test. So therefore, in this case, as we've got to realise that we are rejecting H1, the implication is that therefore we're disagreeing with the claim that was made in the question. So I'm going to start my conclusion off by basically pointing out that I'm disagreeing with the conclusion by saying there's not enough evidence to agree with it. But then we're not just fully disagreeing with the claim, because we're then acknowledging the fact that we're only disagreeing with it because we were working at a 5% significance level. So acknowledging that the size of the significance level contributed to your conclusion is important. But then to finish off the conclusion, you're just making sure that you are relating what you're saying back to the scenario given in the words. And a good way of often doing that is to almost just parrot back the wording given to you in the actual claim itself that you were testing. So in this case, it was about whether the staff satisfaction was less than 90% or not. So therefore, I'm going to say there's not enough evidence at a 5% significance level to suggest that less than 90% of staff are satisfied. So there you go, we've answered the question. And on to example 2, and once again it's worth noting that this wording wasn't shown earlier in the video when we were doing example 2, but this is the wording that was associated with those calculations we were doing with what we called example 2 before. And therefore we had already made the conclusion that we're rejecting h0. But therefore the implication is, if we're rejecting h0, we're not rejecting h1. And h1 is normally what's associated with the claim, so therefore the implication is that we're not disagreeing with what the claim said. And so therefore we're going to say there is enough evidence at a 10% significance level, again referring to the significance level because that had an impact on what we decided. We're going to say that there is enough evidence to suggest that tails might be more likely to come up than heads, in other words agreeing with the claim that was written there. So there we go, we've answered the question. On to example 3. Again, this wording wasn't shown earlier in this video, but this was the wording associated with those calculations we did for example 3, where we decided we were not going to reject h0. So again, read it very carefully, but the implication is if we're not rejecting h0, we're accepting h1, and h1 was related to the claim that was being made, which was the idea that the farmer thinks the proportion was different to the whole variety. So therefore in the conclusion we are saying there's not enough evidence because we're disagreeing with h1, because we're not rejecting h0, we're mentioning the significance level of 8%, and then the wording at the end is again making sure we're relating back to that context, relating directly back to that claim, almost parroting back the wording in that claim to answer it by saying that there is not enough evidence to suggest there is a different proportion of the new variety of parsnip that meets the conformity rules. Basically, not words I come up with myself, I'm just rewording or reusing words that were in the actual question itself. Okay, so that is how you write the conclusion for a binomial hypothesis test. I hope you found this video useful, and of course do check out any other videos on the binomial hypothesis testing, particularly with critical regions, because there's a few little details to watch out with that stuff, because they can change wordings to change how you do the calculations in some cases. But that is us done with this chapter. See you in a future video. Goodbye.